Hello, Azaan.
Yes,
How are you?
fine.
Okay. So we have discussed the image formation by the convex lens. Okay. And we have discussed that when the object is placed between focus, this is focus, and the optical center. Okay. So how the image will form. Okay. This we have discussed. This is focus. So we have seen that the image there is larger than the object, and the image is virtual and erect because the rays are not actually meeting, and the image is forming on the same side of the object. Okay, and this was the assignment. So let's check it out. So the first question they are saying, with the help of ray diagram, differentiate between the converging lens and the diverging lens. So we have discussed this already with the help of ray diagram. This is the ray diagram for the converging lens. Convex lens is a converging lens. You can check the notes, and this is the ray diagram for the diverging lens. Okay, so you have to differentiate both the lenses. So means you can do this question with the help of notes. Now, next question is, in the next question they are saying, explain the following terms related to the spherical lenses. Okay, optical center already I have discussed. Center of curvature already I have this. Center of curvature means uh, principal axis already I have discussed. Okay, focus already I have discussed. Focal length already I have discussed. Center of curvature I have not discussed. Okay, so you can solve from this with the help of note. Optical center, what is principal axis, what is focus, and what is focal length. Okay, and this thing I will discuss. Center of curvature and aperture. Okay. And see the last question. Last question, in the last question they are saying, define the optical center and the principal axis of the lens. So optical center is the center of the lens, and when a ray passing from the optical center, it will not change its path. And what is the, they are asking, what is the principal axis of the lens? So we have already discussed what is the principal axis, and they are saying, show that the path of the refracted ray when a ray of light is there toward the optical center of the concave lens. So in the starting I have discussed what is the optical center. This is the optical center. Okay, the center point of the lens, and here you can see whenever a light ray is passing from the optical center, it will go straight. Okay. So I will tell you the aperture and the center of curvature. Okay. So now let's see this. This is the convex lens. This is the convex lens, and this is the optical center. Suppose this is O. This is O is the optical center, and this point is the focus, or you can say first focus, or you can say principal focus. Okay, this is first focus, I have told you the lenses have two focuses. Okay, if this is focus means this length is f, small f, and again this is 2f. 2f means the distance between this and this is again f. Okay, same is the case here. This is the second focus, and here also this length is f, small f. This length is small f, this length is small f, this length is small f, this length is small f. And we are measuring the distance from the optical center. And object is here now. So earlier what we have done, we have just placed this object between this focus, second focus, and the optical center. So we got this type of image. Okay, Azaan, are you getting?
Yes, sir.
So now what I will do, I will place the object this time on the focus in front of this convex lens, and we will see how the image will form. Okay, so this was our first case. Now we will discuss the second case. And one thing I want to tell you here, uh, this is the see this image, a convex lens being used as a magnifying glass to read the small print of the book, and this is the convex lens. Okay, and suppose if you want to see anything, means you if you want to see the image uh, of the written print or the writing. Okay, if you want the large image, so that you can uh, read that, or you can analyze that image more clearly. So what you will do, you will use a convex lens, and what you will do, you will put the convex lens closer to that book. Okay, closer to that book means what you have to do actually, uh, you have to make a situation like this. The object should be within the focus. Okay, the object should be within the focus. This, okay, object should be within the focus means object here is this book, and this lens, you have this convex lens. Okay, so you will try to manage the lens like that, so that this book should be within the focal length or within the focus of this convex lens. Okay, then you will get a large image. Okay, here you can see here a large image of the object you are getting. So you will get the large text for reading or large image for analyzing. Okay, case number second. Case number second. Suppose this is the convex lens we have, and this point is the optical center. This point is the optical center, and this line is the principal axis. And this is f dash. Here you can see here, this is the first focus, and this is the second focus, and second focus we represent with some different thing. Means this is f, so this is f dash, we will take f dash, and if this is f, so I am now placing the object here. I am now placing the object here at f. So how the image will be formed, you can see here. For the image formation, at least two rays must meet or appear to meet. So this object will give two rays for the image formation. So first ray from this object will be like this, and image from this object is coming like this, which is parallel to this principal axis, and after refraction it will pass from the focus. Okay, and second image from this object will be like this. So you can see that this A and B, this A and B is the object, this AB is the object, and first ray from the object is parallel to this principal axis, and we have discussed that whenever a ray parallel to principal axis, this will pass from the focus. And second thing we have discussed, that whenever a ray will pass from the optical sector, it will go straight. So in actual, these rays will meet at infinite. Okay, so rays will meet at infinite. Infinite. Okay, so image will form at infinite. Image is formed where the rays meet. Okay, so here the rays will meet at infinite, so image will form at infinite. Image at infinite. So now talking about the image, what are the nature and location and size? Number one, uh, as the rays will actually meet, means at infinite, so we can say that the image will be virtual, or image will be real. And if the image is real, then it is inverted also. Second, what about the size of the image? Okay, see, this is AB is the object. This object will be smaller as compared to the image. Okay, so you can say size of the image will be uh, enlarged, or you can say larger than object, or you can say enlarged. Third point is location of the image. Location of the image means where the image is forming. The image is forming at infinite. Uh, Here the image will be formed, you can say the highly enlarged. Image will be enlarged but highly enlarged. This highly enlarged means much larger than object. And the position of the image at infinite. This is the nature. This is size. This is the position. And this is the case when we have placed the object at focus. This is f dash, and suppose this is 2f dash, and this is f, and this is 2f. Okay. So here I have discussed what is f and what is 2f. This thing. So now I am placing the object between this f and f dash and 2f dash. Okay, I am placing the object between this f dash and 2f dash. This is case number third. Object between f dash and 2f dash. Same thing you have to do. Now also you have an object. This is the object you have, and what you will do, from this object at least two rays is we need for the image formation. So these rays meet somewhere here. Okay. This is, so see here again, object was here. This is the object, and one ray from the object is like this, and this is parallel to the principal axis, and after reflection it will pass from the focus. So suppose this point is the focus now. So I'm changing a little bit. This point is the focus, and this ray will go like this, and second ray from the object is again passing from the optical center, and this will go straight and meet at this point. Means both rays will meet at this point. So you can say that this is the image. This is the image, and this is your object. This is your object, this is your image. So now talking about the image, nature, position, and the size. So first of all, nature of the image, as you can see, these rays are meeting actually. So you will say the image will be real, and you can see from here the image is inverted also. So image will be real and inverted. Second thing, what about the size of the image? See the size of the object, see the size of the image. So you can say larger than object. Larger than object, or this term is also known as magnified. Number third, the position of the image. For the position of the image, you will say this image is forming beyond 2f. Okay, image is forming beyond 2f. Okay, now we will discuss the fourth case. Azaan, are you getting?
Yes, sir.
Same thing we are doing as we have already done in case of mirrors, but there the reflection was taking place. Here the reflection is taking place. Now this is our lens, okay, and this point O is the optical center, and this line is the principal axis, and this is f dash, means you can say second focus. This is 2f dash, and so now I am placing the object at f2 f dash. This is the object I am placing. So what will happen? You can see here. First ray from this will be like this, and it will pass from the focus. It will pass from the focus like this, and second ray will be like this. Meet at some point. Okay. First ray is like this. This will pass from the focus. Second ray will be like this, and both the rays will meet at some point, and this is the image. At and this distance will be 2f. This is f. Okay. So our object. This is our object. Okay. This is the image. So first ray is like this, parallel to principal axis, will pass from the focus, and second ray will be passing from optical center, and both rays will meet at this point, and the image will be formed at 2f. So about the image, the image will be real and inverted. You can check it out from the diagram, because the rays are actually meeting at a point. Secondly, about the size of the image, this will be a same size as object. And talking about the position, so you will say at 2f. This is the case when the object is at 2f dash. Fifth case, when you will place the object beyond 2f dash. So suppose this is f dash, this is 2f dash, and our object is here. Okay, so what we will do, for the image formation, first ray will be like this, and it will pass from the focus. And second ray will be like this. Both rays will meet at some point right here. Take this as object, and I'm changing it little bit. To pass from the focus, and second ray will be like this, passing from this. Here, So now I can explain it. Hmm. First ray from this object is parallel to principal axis will pass from the focus. This will pass from the focus after reflection, and second ray from this object will passing from the optical center and meet at this point. And this is the image, and this is object. Okay, so image, what you will say about the image will be, you can see here, image will be real and inverted. Second, smaller than object, about the size if you are talking. Number third, so this image will be in between f and 2f. Okay, when you will measure the distance, you will get somewhere here will be 2f. So image will be between f and 2f. Okay, the last case I am going to discuss, when the object at infinite. What will happen when the object at infinite? So when the object at infinite, so means the rays will come from the infinite, means uh, the rays will come from the infinite, and from infinite always the parallel rays, there are parallel rays originated from the infinite. So, and these rays will be like this. This is, these are rays from infinite. These are rays from infinite. Okay, and after refraction, these rays will meet at a point, and this point will be the focus. Okay, means these rays will meet here, which is at a distance of a small f, or you can say at this point focus. Means the rays are not meeting at focus actually. Okay, the rays are meeting at the focal plane. Okay, I have told you what is focal plane earlier. So this is the case. Number 6. See here. See this case. In this case, this object is larger and image is smaller. So in real life, what happens? You can see. Okay, see here. In this image, what is happening? This is the bulb, and this is the length. Okay, this is the bulb and this is the length. And if you are placing this bulb, and this bulb is the object, if you are placing this bulb at a distance greater than 2f dash, okay, so you can see this is the image of this bulb. This is the image of this bulb, and this image will be smaller than object. Okay, same is the case here. Object is larger, image is smaller. So all the things you can perform experimentally. Okay, Azaan. So just note it down from here. Azaan, are you getting?
Yes.
Yeah, you should note all the things, and do not copy this. Okay, this diagram. This is just for your understanding, but you can copy this. Here, small f is the focal length, and focal length is a distance between the optical center and the focus. F is the distance between O and F, and same distance is between F and 2F. You can see here when you use the convex lens as a magnifying glass to read the small print. So what you will do, you have to put the book at a distance in between, or you can say at a distance less than the focal length. Okay, or this book should be at a distance, or you can say this book should be within focus or between the optical center and the focus. Then you will get the magnified image, virtual and magnified image. Completed this?
Yes.
Okay. Now note this. The question can appear in your examination that draw the ray diagram ray diagram when the object is at the focus of convex lens. Okay. So you will draw the ray diagram like this. For the image formation, you will need at least two rays. So you will show the ray diagram of two rays, and that will be sufficient. Azaan, are you writing this or have you completed?
Sir, I'm writing. Sir. Sir, no.
This is the case when the object is in between f dash and 2f dash. You will get this type of ray diagram.
Done, sir.
This is the case when the object is at 2f and we will get the image at 2f and of same size as object, and the image will be real and inverted. Why real? Because the rays are actually meeting at a point, and inverted you can see the direction you can identify the inverted image from the direction of arrow. If the direction of arrow in image and object is same, then the image is erect. If the direction is opposite, then the image is inverted. Then you have not sent me the mathematics test solution.
Sir, I have sent, sir.
You have sent,
Yes, sir.
but I have not got it. Where you have sent it? On the group,
No, sir, on your number.
on my number. Okay. Okay, Azaan, do you have that PDF of
Sir,
test?
PDF means.
PDF means the images If you don't know about the PDF, then I have told you, you can send me the PDF. You have sent me the images or PDF,
Sir, images.
but I have not got the images. You can send me again, okay?
Okay, sir, I'll see. Sir, can you scroll down?
Yeah, yeah. This is the case when the object is beyond 2f. So if the object is beyond 2f here, see the image will be in between focus and between f and 2f, and the image will be smaller than object, and image will be real and inverted. So now I think you will be comfortable with this. Azan, I want that you should attend the classes regularly. Okay.
Done, sir.
Don't miss any class. So this is all about the image formation by the convex lens. Here we have placed the object at different position, and accordingly we have get the images. After completing Azan, you can leave the class and we will meet in the next class. And please send me the images of that test again.
Okay, sir, I will check if it is there.
You can leave the class after